My colleague, the volcanologist Ármann Höskuldsson, believes that the tension under the Grindavík will take 10 years to be relieved and mapped after that to know the amount and the degree and the location of all the damages and sinkholes and cracks to be recorded for the safety and starting the life again. Eruption and volcanism is part of the process, although it will affect the bedrock, the basaltic, the structure that is related to geology there, and they are going on fast and furious, and there is no sign of it subsiding any sooner. Magma rises, as we know, the mid-oceanic ridge is extending. Magma rises, reaches the surface, erupts. This will create cracks in the ground, weaknesses in the rock. Bedrock, of course, reacts to that, it splits. We try to fill them up, but man-made structures doesn't react the same way that the natural rock behaves. Natural rocks can be welded together or joined together, eventually, subsiding in a way that settles. But the man-made structure may hide those cavities. If we fill them up on top, they will not collapse immediately. They will keep a surface which looks normal, and then over time, as the erosion, as the dissolution of the material, sand and concrete happens, we will end up with numerous cracks, sinkholes, subsidence that we don't have any evidence for them until they happen. And when they happen, that is the damage done. So for this to actually be correctly mapped and the town be safely built again, we have to wait this natural process, this cycle of 10 years, take over, and then after that, we can think about the rebuilding it. Bedrock and volcanic rock have to settle. Then after that, we can actually start to build over them again with our man-made material. I have videos about these 10 years, why it was 10 years, for example, for Krefla fires, and why I think it takes for the vegetable system another 10 years. I'll put the videos at the end, you can watch them also. What's happening to the Svartsengi and Grindavík is not unique. We have a historical case for this thing, and I will analyze it for you. In the early November, 10 and 11th November, we had a swarm of earthquakes in the area from the Blue Lagoon or Svartsengi to the Thorbjorn and the Grindavik. We had a rock fall, rocks from the cliffs falling down, and the cracks appearing in the ground that we can see now. The result of the magma pushing under the rocks and lifting the land was this rock falls. We had the evidence for it. By the GPS data, interferometry also showed us that the magma is accumulated under this area and is evolving, is gradually rising the ground. We had extension also due to the mid-Atlantic ridge being opened. The result of it was a fall in the Grindavik to the Blue Lagoon area and rise on both sides of it. It's practically a rift valley forming there. This rift valley has now gradually subsiding in the way of activity, but we have parallels to this in the Krafla volcano in the north of Iceland, in the similar setting when we had uplift and downfall, between each eruption. Magma needs to accumulate between the big events that they don't reach the ground. We have a smaller event that gradually build up magma under the crust, and then this erupts eventually. We had 9 eruption events and 15 uplifts during the Krafla fires. This was famous from 1975 to 1984, and this is all related to this activity by the pulling of the earth crust, stretching it, rising the magma because of the cavity created. Magma rises, depressurizes, the gas bubbles forms, creates pressure, and eventually reach the surface. We are just at the beginning of this in the Grindavík and the Sortsengi and Blue Lagoon area. A lot of things have yet to happen. This is just the first stage of it. It may happen tomorrow, it may happen in several months from now, but this will eventually happen. This is the event that we have seen in Krefla is going to happen here again, it seems. When the mid-Atlantic reaches Iceland, it has created several peninsulas. One of them is the Reykjanes Peninsula, created by the volcanic system that you see the names of them here. They are tectonically similar to the bowden edge structure, shear structures that we see in the rocks. Is extension creating fault lines, and the fault lines, through them the lava may erupt. We see them in micro scale in the rocks. You can make it with a plasticine if you have the time. A model of that, and the extension can create fault lines that the lava can rise through them. In the case of the systems, these systems are directly connected to the mantle. Fagradalsfjall volcano was such a volcanic system. We found that with this discovery that this Fagradalsfjall was connected actually to the earth mantle through a dike. The dike is fed by the mantle. And as the eruption happens in this area in 2021 in Fagradalsfjall, 22 in the Meradil, and Litla in the 2023, it may happen and extend to the years beyond. From 2025 will be a slight angle toward the east, as you see in the other systems parallel to it toward the east. And by 2030, it's quite possible that this system may reach the Reykjanes or the suburbs of it. This is the day that you will see the volcanoes actually erupting inside the town or near the outskirts of the town. This is a scary scenario. And this is one of the several scenarios that may happen. This volcanic system may not reach as far as the Reykjavik, but in this model that I presented, if it reaches there, that will be just outskirts of the town.